Sketching the graphs of functions, part 5. Finding equations for given cubic graphs. The graph of a function is shown on the right, so the red curve. So we know straight away just by looking at this that this is a cubic function because it's a sideways S shape, and it goes down, then it turns and goes up, and then it turns and goes down again. So it's a negative cubic graph. So it starts off with minus something x cubed. We can see it intersects the x-axis at x equals minus 2, 0, and 2. So it crosses the x-axis, or it intersects the x-axis at minus 2, 0, and 2. This function will contain x multiplied by x plus 2 multiplied by x minus 2 as part of the expression. Notice that the graph also contains the point 1, 1. So that's that point there. To accommodate this condition, the equation of the function will take the form y is equal to k times x plus 2 times x minus 2, where k is a number to be found, so k is unknown. We use the fact that 1, 1 is on the graph to find the value of k. Now 1, 1 is just the point on this graph. It could be any point, it won't always be 1, 1. So 1, 1 is an element of the graph y is equal to k times x plus 2 times x minus 2. So we're going to sub in x equals 1 and y is equal to 2. We're going to replace the x with 1 and the y with 2 and solve for k. So the y becomes 1 and the first x there becomes 1, so we've got 1 with brackets around it. Then that x becomes 1 as well, so 1 plus 2 makes 3. And that x becomes 1 as well, so 1 minus 2 is minus 1. So we have 1 equals k times 1 times 3 times minus 1. So 1 times 3 times minus 1 is minus 3. So we've minus 3k is equal to 1. And solving for k is equal to minus a third. So the equation that we started off with, so y is equal to k times x plus 2 times x minus 2. That k we now replace with minus a third. Therefore, the equation of the function is y is equal to minus a third times x plus 2 times x minus 2, i.e. y is equal to minus x over 3, which is the same thing as minus a third x, times x plus 2 times x minus 2, or if you want to multiply out the brackets and simplify, you would end up with y is equal to minus a third x cubed plus 4 over 3x. So to set up the equation, so we always use k as our unknown when we're doing this question, but to set up this equation, it all depends on where the graph crosses the x-axis. So it crossed at minus 2, so x plus 2 was a factor. It crossed at positive 2, so x minus 2 is a factor. And if it crosses at the origin, so 0, 0, then x on its own is a factor. If a graph touches but does not cross the x-axis at a point, a double root occurs at this point. So for example, here we have a U-shaped graph. So this is a quadratic graph and it touches the x-axis, but it turns and it doesn't actually cross the x-axis. So it just touches it and then it turns. So it's going downwards and then it turns and then it goes upwards again. So this function is x squared minus 8x plus 16, which can be simplified as x minus 4 to be squared. So the main point here is that it just touches the graph. It just touches the x-axis at the point 4. So this is known as a double root. This point can either be a local maximum or a minimum turning point. In the case of this graph, it's a local minimum turning point because it's a U-shaped graph. As in the graph, f of x equals x minus 4 to be squared. The roots at 0, so we let 0 equal x minus 4 times x minus 4, because x minus 4 to be squared is x minus 4 times x minus 4. So therefore, there's a double root at x is equal to positive 4. So since we've got x minus 4 and x minus 4 as our brackets, then x is equal to 4 is going to be where the double root is at. So we can see that's where the minimum turning point is. So when you have double roots like this, you get what's known as a turning point. So it doesn't cut through the graph, or the x-axis. That's really important. So for example, like if this said x minus 6 times x minus 6, then the graph would just touch 6 on the x-axis. It wouldn't cut through the x-axis at 6. Whereas if the graph was missing one of these x minus 4s and just had a single x minus 4 as one of the factors, then it would have cut through the x-axis in some sort of way. And likewise, if we only had a single factor of x minus 6 here and there wasn't two x minus 6s, then it would cut through the x-axis at 6, and so on. So there's a double root at x is equal to 4. So it touches 4, but it turns and it doesn't actually go through 4. We also note that f dash x, so the derivative, is equal to 2x minus 8. So going up to our original function, so f of x equals x squared minus 8x plus 16. So the derivative of x squared is 2x. We bring the power down in front, so the 2 comes down in front of the x, and we reduce the power by 1. 2 minus 1 is 1, so we just get 2x. And then minus 8x, we just cross off the x, so we get minus 8. And then 16 is a constant, so that becomes 0, so we just don't write anything down. So the derivative of this function is 2x minus 8. So the derivative is equal to 0 at x is equal to 4, i.e. a turning point is at x is equal to 4. Find the equation of the given graphed function and prove using calculus that the function has stationary points at 2, 0 and 0, 2. So we see it's an S-shaped graph, so it's a cubic function, so we know x cubed is contained in the equation. It starts off by going upwards, then it turns and goes downwards, and then it turns and goes upwards again. So it's going to be positive x squared because it starts off by going upwards. It crosses the y-axis at 2. So 0, 2 is going to be one of the points on the graph, and it also happens to be the maximum turning point. It crosses the x-axis at minus 1. So x plus 1 is going to be a factor. There is a double root at x is equal to 2 because it touches 2, but it doesn't cut through 2. It just turns and goes upwards. So we know that x minus 2 and x minus 2 will be factors. So x minus 2 squared is going to be a factor. And another point that's on the graph that's going to be helpful to us is 3, 2. So that's all the information that we can see from the graph straight away. So the graph intersects the x-axis at minus 1, 0, i.e. when x is equal to minus 1. So that's that point there where it's cutting through the x-axis. The graph touches the x-axis at 2, 0, i.e. when x is equal to 2. So again, it just touches the x-axis, but it doesn't cut through it. So that's where you want to think double root. The equation therefore has the form y equals k, so some unknown value, k, times x plus 1 times x minus 2 to be squared. So the factor x plus 1 comes from here. If x is equal to minus 1, then a factor must be x plus 1. And then the x minus 2 to be squared comes from here. If it touches the x-axis at 2, but it turns and keeps going and doesn't actually cut through the x-axis, then you know you have a double root here. So you have x minus 2 to be squared. So since this is positive 2, we have minus 2 in the brackets. So we're going to take the point that was given 3, 2, and we're going to sub it into the equation. So we're going to swap the x for 3 and the y for 2, and then we're going to solve for k. So we replace the y with 2, and we replace each of the x's with 3. And then we simplify and solve for k. So we get 2 times k times 4 times 1. So 2 equals 4k. So k equals 2 over 4. So k is equal to a half. So k is equal to a half. We got that from the previous slide. Therefore, the equation is in the form of y is equal to a half times x plus 1 times x minus 2 to be squared. So we are going to multiply out the brackets. So a half times x is a half x, and a half times 1 is a half, and then x minus 2 to be squared is x minus 2 times x minus 2. So x minus 2 times x minus 2 gives us x squared minus 4x plus 4. So then we're going to do a half x times x squared minus 4x plus 4, and then plus half times x squared minus 4x plus 4. So I've just wrote this out from the previous slide. So a half x times x squared is a half x cubed. A half x times minus 4x is minus 2x squared. A half x times 4 is 2x. A half times x squared is a half x squared. A half times minus 4x is minus 2x. A half times 4 is 2. The 2x and the minus 2x will cancel, and we're left with y is equal to a half x cubed minus 3 over 2x squared plus 2, which we can rewrite as y is equal to x cubed over 2 minus 3x squared over 2 plus 2. So either will do. Both are correct. So y dash, or the derivative, is going to be 3 over 2x squared minus 6 over 2x. So what I did was I brought the 3 down in front. So 3 multiplied by a half is 3 over 2. And then the power 3 gets reduced by 1, so we get x squared. And then we bring the power down in front, so 2 multiplied by minus 3 over 2 is going to be minus 6 over 2. And then the squared will be reduced by 1, so 2 minus 1 is 1. So x to the power 1 is just x. And then the derivative of 2 is just 0, so we don't need to bother writing out 0. So just simplifying, minus 6 over 2 is a minus 3. And factorizing, we get x times 3 over 2x minus 3, just to put it in its simplest form. So that's the derivative of our function. So our function, we worked out to be y equals x cubed over 2 minus 3x squared over 2 plus 2. And our derivative, we worked out to be x times 3x over 2 minus 3. So we're going to take the derivative and we're going to let it equal to 0. So we have 0 equals x times 3x over 2 minus 3. So x is equal to 0, and then 3x over 2 minus 3 is equal to 0. So 3x over 2 is equal to positive 3. Multiplying both sides by 2 to get rid of the fraction part gives us 3x is equal to 6. Therefore, x is equal to 6 over 3, so x is equal to 2. So our two solutions is x is equal to 0 and x is equal to 2. So we worked out the derivative of our function, we let it equal to 0, and then we solved for x, and we got two x values. So again, our two x values are 0 and 2. So we're going to work out now f of 0. So we go back to our original function. So y is equal to x cubed over 2 minus 3x squared over 2 plus 2. And we're going to substitute 0 in place of both of those x's. So f of 0 becomes 0 cubed over 2 minus 3 times 0 squared over 2 plus 2, which equals 2. Therefore, we have a stationary point at 0, 2. So we let the x be 0, and we got an output of 2, so we got a y value of 2, so that's where the 0, 2 comes from. So that's one of our stationary points. So now we're going to do the same thing, but this time we're going to sub in 2, x is equal to 2, into the original function. So f of 2, so we're going to replace both of those x's with 2, so we have 2 cubed over 2 minus 3 times 2 squared over 2 plus 2, which gives us 0. Therefore, we have another stationary point at 2, 0. So we subbed in 2 as our x value. We got an output of 0 as our y value. So 2, 0 is our other stationary point. So we were asked to find the equation, which we did. So the top line there is our actual equation of this function. And then to prove using calculus, so using derivatives, that the function has stationary points at 2, 0 and 0, 2, which we can see from the graph it does, the maximum turning point and the minimum turning point. But we've proven now through calculus that they are indeed 0, 2 and 2, 0.